Okay, folks, I'd like to do what we call the CoCo CC proof real quick. And to do so, we need a little bit of background information here. Recall the distance formula is x minus x quantity squared plus y minus y quantity squared. Cosine is always going to be our x value, sine is going to be our y value, and cosine squared plus sine squared always equals 1. All right, so here I have 2 points, A and B. All right, this point A and this point B on the circle, right? It's a unit circle with a radius of 1. The x value would be cosine A. The y value would be sine A. As I move over here to B, this would be cosine B, comma, sine B. And what I want to show you is if I took these 2 points, A and B, let's call this A, and let's call this B, and I shifted them along the x-axis, or along the edge of the circle, this angle right here, we would call A minus B. Okay, that would be the angle between A and B, shifted all the way down to the x-axis. Okay, so then this point right here is now A minus B. So we would call this cosine of A minus B and sine of A minus B. All right, and of course this point here is 1, 0. So what we're going to do is we're going to use the distance formula to prove some stuff. So what are we going to prove? In the very end, we're going to prove this cool identity, which tells us that cosine of A minus B is going to equal cosine A cosine B plus sine A sine B. And we're going to be able to apply that to a bunch of different situations. So let's get started. I'm going to find the distance, the straight line distance here between A minus B and the point 1, 0. Okay, so I'm gonna do that first. Let's do that in green. So that distance, right, would be the square root of x minus x. So our first x was cosine A minus B. Our second x was 1. Square it. Our y's were sine of A minus B and 0, right? So I'm not going to put the 0 in there. I'm just going to square that. Now, technically speaking, that should be equal to, on the other side, the distance between A and B up here. I'm going to do that in red. Okay, so here we go. So the distance between A and B, we need a little bit more space, is going to be cosine A, so x minus x, quantity squared, plus y minus y. And it doesn't matter the direction you go in because we're just going to square these and square that. So I've got some algebra to do. Okay, let's do some stuff here. Let's expand this, right? I got to FOIL that. So cosine squared A minus B, you can follow along at home and just watch, minus 2 cosine A minus B, okay, plus 1. So if I expand that, that's what I get. All right, and I'm going to drop the radical because both sides are square root, so I can just square both sides and get rid of it. So just assume that I've done that. Okay. And then here, this piece, if I square that, I just get sine squared A minus B. So I kind of like that because it's very simple. Okay. On the right side, I might have to, I might run out of some space here, but that's okay. Okay, if I FOIL this, right, I'm going to get a cosine squared A minus 2 cosine A cosine B plus cosine squared B. Okay, so far so good, I hope. Okay, let's keep going. Let's do the same thing with sine, and nicely it's going to line up very well with what we just did with the cosine, except it'll be a sine value. So it'll be a sine squared A minus 2 sine A sine B plus sine squared B. Okay, so I know that these two are equivalent, right? This whole side I kind of had to compact into 2 lines, but that's okay. I'm going to look for some identities here real quick. All right, so let's take a quick look. And the first identity I want to look at is sine squared plus cosine squared equals 1. But the angle has to be the same. So if I look over here, I see cosine squared A minus B. Okay, if I can find a sine squared A minus B, oh, I do. I have one. I know that those two added together would be 1. I'll fill that in a moment. Okay, now check this out. I've got another 1. Okay, so I got a 1 here. I got another 1. Maybe I should do that in a different color. Let's do that in a different color. We'll do that in blue. I got another 1, so that takes care of that. And then this piece here, this 2 cosine A minus B right here, I'm not going to be able to do anything with that, so I'm just going to leave it as is. Okay, so I've got a 1 plus 1 minus 2 cosine A minus B. All right, and that takes care of everything on the left side. Let's look on the right side now. Let's go with purple. Ooh, that might not look very good. How about green? Okay. Cosine squared A. Now I'm looking for a sine squared A. Do I have one? Yes, I do. That would equal 1. Okay. Do I have a cosine squared B? Yes, I do. I'm going to go, just for the sake of simplicity here, I'm going to go blue, cosine squared B, sine squared B. I get another 1. And then I'm left with this stuff, right? These 2 items. I'm not going to be able to do much with that other than in a moment I'll be able to do some work with it to reduce it a little bit. So I get that 1. I get another 1. And then I'm left with minus 2 cosine A cosine B minus 2 sine A sine B. So hopefully so far you've been able to stick with me. Now check this out. If I have a 2 on both sides like this, they're going to cancel. Okay, so then what I've got here is negative 2 cosine A minus B equals negative 2 cosine A cosine B minus 2 sine A sine B. You might see it already, but I'm going to divide both sides by negative 2. And you guys, our proof is almost complete. This is one of the toughest proofs you'll probably experience in your pre-calc. But we get what we wanted, which is cosine of A minus B equals cosine A cosine B plus, now here's the key, when I divide this negative 2 out here, here, and here, they all become positives. Sine A, sine B. Okay, and with that, there is an alternative proof. We're not going to do it today, but it says that cosine of A plus B, very similarly related, is cosine A, cosine B, sine A, sine B, but instead of plus like we have here, we're going to have a minus. Okay, so those are 2 very, 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 very foundational properties for sum and difference angles. Peace out.